Hello, good afternoon. Welcome to today's webinar from Cara Technology. My name is Genevieve. I am a master brewer and the customer education manager here at Cara Technology. Before my role here, I was in brewery management, quality, R&D, operations management as well. So just to give some context to what I'm talking about, hopefully it's things that you might have come across in your day-to-day in the brewery. Certainly applies to some of the projects that I've worked on in my time. Um, at Cara Technology, we are dedicated to helping breweries like yours achieve consistency and excellence. So the business was founded in 1995 and has proudly supported drinks production companies across more than 170 countries, providing expertise and resources to elevate product quality worldwide. So, today we're going to explore how breweries can balance the drive for greater sustainability with the uncompromising demand for sensory excellence, identifying the risks, applying practical tools, and adopting best practices to ensure that beer's taste and aroma remains consistent as processes and ingredients evolve. But before we dive in, remember you can submit questions at any time through the webinar in the Q&A function on Zoom, and I will address those at the end of the session. If we run out of time, please be reassured we'll follow up on additional questions by email. And after the last webinar, we received a few more questions via email. So if you don't think of it during the session but want to ask afterwards, please reach out. There'll be an email address you can reach us on later on in the session. Think about your own experiences as we go along. Please share any relevant experiences with us. We always love to learn from your stories as much as our own. Now, as the brewing industry faces growing environmental and economic pressures, sustainability has become a key driver of process innovation. Brewers are implementing energy-saving processes, alternative ingredients, water and CO2 reuse systems, that sort of thing, all with the aim of reducing environmental impact and improving efficiency. However, nearly every sustainability measure touches a point in the brewing process that can dramatically affect sensory outcomes. Now, these changes might seem minor at time, maybe a slight alteration in a boil-off rate, a switch to a lower carbon malt supply, or choosing to sponge your fermentation tanks to capture natural CO2 recovery, natural CO2 rather than a more forced carbonation protocol. But small adjustments can accumulate, and the result is flavour drift, inconsistencies, and changes in mouthfeel, aroma, flavour that can all erode consumer trust. The issue is that without structured sensory evaluation, a lot of these changes go unnoticed. Teams may adapt to a new flavour baseline without realising it. And when changes happen slowly or incrementally, they're much harder to detect. And this puts the brand at risk, especially in today's quality-driven and brand-loyal beer market. So that's why sensory testing shouldn't be an afterthought or reserved for product development only. It needs to be embedded directly into sustainability planning. When we say sustainability decisions are process decisions, we also have to acknowledge that all process decisions are sensory decisions. Sensory control becomes not just a sensory control becomes not just a QA tool, it's a risk management and innovation guide. The goal is not to balance sustainability against quality, it's to protect quality through sensory control. So at the recent CIBD 2025 Sustainability Conference, someone said something simple but really important. Water is the most sustainable drink that is out there. And if sustainability was the only thing on people's minds, they'd just drink water. But they don't. They choose beer because they enjoy the taste and the experience it brings. Sustainability absolutely has a place in our work, but it shouldn't come at the cost of quality or product consistency. Because at the end of the day, it's the consistent, great tasting beer that keeps people coming back time after time. When we focus on quality first, sustainability efforts support that and they don't replace it. So, as brewers, our job is to make sure that every batch delivers the experience people expect and love. Now, before we talk about how to manage sensory impact, let's address a few questions, or a key question specifically. Why is sensory so often left out of the sustainability conversation? Well, first, the focus in sustainability work is often based on simple to gather numerical data. So carbon numbers, water usage, energy draw, they're all very trackable. Flavour is much harder to measure, so it often falls off the radar unless there's a really clear issue. Secondly, The teams driving sustainability are generally process engineers, operations and project leads, sustainability managers. And often they aren't trained to think about flavour risk. And if sensory focused teams aren't part of the conversation early on, issues only get flagged after implementation. Finally, there's a psychological bias at play. Green equals good, so changes made in the name of sustainability are often assumed to be safe. But we know even positive interventions can have unintended sensory effects, especially when they interact with raw materials or fermentation dynamics. Analytical techniques like gas chromatography are widely used to give a snapshot of a product's chemical profile, and they're often relied upon in supply chains and research projects to quickly show that key compounds fall within expected ranges. But when it comes to operational flavour consistency, that kind of data lacks the resolution needed. Flavour perception is not related to concentration. It's all about perception thresholds, which vary significantly between taste and aroma compounds. So take geosmin as an example. It barely registers on a GC trace at parts per trillion levels generally, yet it has a really powerful earthy off note detectable by humans in just a handful of molecules. It presents a significant impact to product flavour, but might be purely missed if we only relied on analytical measurement. Meanwhile, a compound like isoamyl alcohol may appear in really large quantities on a gas chromatogram, but contributes minimally in flavour intensity in beer. Then there's also the issue of isomer differentiation. So analytical tools often can't distinguish between isomers that can taste radically different. An example I like to give on this within the world of beer would be trans-2-nonenal, which has a papery taste, while cis-6-nonenal brings a fresh melon character. They are very similar structurally, but completely different on the palate. But on a gas chromatograph, these two compounds would show in the same measurement spike. So this is where trained sensory panels are more valuable. They don't just detect the presence of a compound, they interpret it in the context of how people actually experience flavour. One of the biggest quality threats in modern brewing isn't contamination or off flavour, it's that profile drift as a result of complacency. So this is when your beer gradually changes over time due to a series of small, often well-intentioned adjustments. Profile drift is subtle. Brewers become desensitized to small incremental changes over time. But consumers who are tasting less frequently but with strong expectations detect them straight away. And it often stems from small cumulative changes, so that adjusted boil time or that subtle shift in fermentation temperature. The result is a beer that technically meets analytical specs, but doesn't taste like your beer. Without control samples, trained panels, and sensory tracking, drift can go unchallenged, and protecting brand integrity means putting systems in place to catch and correct that drift before your customers do. So, having talked there about why sensory control is so important and highlighted the risks of profile drifts, let's get a bit more practical. Sustainability driven changes come in a lot of forms, and their impacts on flavour can be subtle but significant. So, over the next few slides, I'll share a few examples of common first round sustainability initiatives and how they can affect flavour, aroma, or consistency. So keep in mind these examples are definitely not exhaustive. Every brewery's process and ingredients differ. Other flavour impacts can and will arise depending on the specific nature of the process modifications and materials involved. So start off with boil time. Many breweries adopt reduced boil times or lower boil intensities to save energy and meet their sustainability targets. During wort boiling, heat causes volatile sulfur compounds, primarily dimethyl sulfide precursors, to evaporate and leave the wort. When boil time or intensity is reduced, this evaporation can be incomplete, allowing more DMS precursors to remain. After fermentation, these precursors convert into DMS, which imparts that sweet corn or tomato sauce aroma. Similarly, incomplete removal of sulfur compounds can lead to elevated dimethyl disulfide or dimethyl trisulfide, causing rotten vegetable or onion-like aromas in the finished beer. Reduced boil intensity also lowers protein coagulation, affecting wort clarity and beer stability. Shorter boil times reduce the Maillard reactions, which can result in variations in colour and less complex flavour profiles forming, and decrease hop isomerization as well, leading to perhaps reduced bitterness and reduced hop aroma. There's also an increased risk of microbial contamination due to less time at boiling temperature, and altered work concentration from reduced evaporation can impact mouthfeel and flavour balance. Now, the widely reported simmer and strip technique exemplifies the sustainability of this approach to sustainability by simmering wort at lower temperatures and stripping out the volatiles. While it's effective, it does require tight sensory and process controls to avoid flavour issues. Now, because a large multinational brewer carried out the research initially, it's tempting for other brewers to think that they can adopt similar reduced boil methods risk-free. But differences in scale, recipe design, equipment configuration, and understanding of the principles can change how flavour active compounds behave. So, adopting these sustainability driven changes means revalidating them with structured sensory evaluation rather than assuming that they will work as an off the shelf sustainability solution. Onto CO2. CO2 prices and availability have been unpredictable for well over a decade, driven by industrial demand and supply chain shocks. Recovery systems offer brewers a way to stabilize this critical impact by capturing CO2 from fermentation, which would otherwise be wasted. Breweries produced large volumes of CO2 as a natural byproduct of their fermentation, and recovery systems finally put that underused stream to work. It's a resource efficiency win, turning a waste product into a valuable input. Now, these CO2 recovery systems use scrubbing and compression skids to clean and store gas that would otherwise be vented to atmosphere. Brewery teams, however, often lack a lot of experience in how they behave, how to maintain them, and how to spot early warning signs of issues like volatile carryover or cross-contamination. The risk with this isn't what we know, it's what we don't know we don't know. And when the system is tied to a flavour critical input like CO2, that's definitely not the blind spot that you want. Breweries need not just to invest in the equipment, but also training, monitoring protocols, and sensory checkpoints, and these need to be built into the process. If scrubbing is incomplete, volatile compounds like esters, sulfur compounds, or solventy aldehydes can carry over into the recovered gas and re enter the finished beer. Shared gas lines or unmonitored condensate traps can enable microbial contamination between vessels. Compressors and pumps introduce mechanical risks like oil or lubricant taints, especially if seals or filters degrade over time. Now, these systems require not just process expertise, but also preventative maintenance, gas purity monitoring, and structured sensory testing to validate safety and quality. Breweries seeking a quicker fix with less capital investment on CO2 may well turn to spunding, that traditional German method where the fermenter is sealed partway through fermentation to trap naturally produced CO2 for carbonation. And while it's simple in concept, spunding carries real flavour risks if it's not carefully managed. Sealing the tank too early can trap volatile esters and sulfur compounds that would normally vent off, resulting in overly fruity or sulfury notes in the finished product. Top pressure also affects yeast physiology. It can suppress ester formation in some strains, increase sulfur retention, or even cause under-attenuation due to metabolic stress. Not all yeast strains tolerate pressure well, and pressure effects also depend on oxygen and work gravity. The flavour outcome is often unpredictable without proper validation. Over time, reduced yeast viability can occur with repeated pressurized fermentations, impacting its ability to flocculate, attenuate, and perform consistently. And without robust SOPs and operator training, batch to batch variation becomes an even more real concern. Unlike CO2 recovery systems, which are typically planned, validated, and automated, spunding is often introduced informally based on traditions or anecdotes. And the logic might be if the Germans have used it for decades, it must be good. But when you're applying it to different beer styles, equipment, and fermentation regimes, again, that assumption can lead to flavour drift. Any process change, even if it's a traditional one, needs the same level of scrutiny, validation, and sensory control. Sustainability in packaging is a major opportunity. Using lighter materials reduces transport emissions, and increasing recycled content supports circularity goals. But again, these changes also come with potential sensory risks that are often overlooked. Shifting from glass to cans, for example, alters the oxygen ingress profile. While cans can offer excellent protection, they behave differently than glass, and any format change needs to be validated sensorially, not just operationally. Lightweight glass might have thinner walls or be a paler colour, which can reduce the UV protection and increase the risk of light struck off flavours, especially in those hop forward styles. Higher recycled content in materials like glass, plastic, or aluminium can also carry legacy contaminants from lubricants, adhesives, or volatile inks, which may then migrate into the beer and cause flavour taints. Even a small material change can influence oxidation, pack aroma, or head retention, especially if internal coatings or surface chemistry alter foam active compound behavior. And color variation in recycled glass can shift how much light gets through, making shelf life performance less predictable as well. While packaging suppliers often conduct migration and compliance testing, it's ultimately the brewery's responsibility to confirm that flavour integrity is maintained. That means validating with real beer in real packaging and using structured sensory methods. Onto malting. Malting is an energy and water intensive process, so maltsters are adopting several approaches to reduce their carbon footprints. Reduced kilning temperatures and drying times may seem straightforward for sustainability wins, but they can cause subtle flavour and mouthfeel differences that will accumulate over time. These small changes can gradually erode long-term brand consistency, so it's important to remember that raw materials themselves are at risk of profile drift when new production methods are adopted. Water recycling in malting, while environmentally beneficial, carries potential risks of introducing off flavours or microbial issues. These sensory defects can harm a brand's reputation if they aren't fully validated when adopting into your brewing process. Local barley sourcing is another factor to consider. New barley varieties or changes in crop quality can introduce batch to batch variability in flavour profiles, making it challenging to maintain a stable sensory experience. Without robust sensory controls, this variability can cause consumer confusion or dissatisfaction. Maltsters encourage you to blend between different seasons of malt to minimize sudden performance variation. Changing to lower carbon cereals carries a similar type of product risk. Adopting the use of unmalted grains as well introduces further sensory uncertainty. Altered enzyme levels and different flavor contributions can lead to unexpected differences in the final beer. And this may manifest as increased haze, astringency, or unusual grain notes that shift the brand's characteristic taste and mouthfeel. So, without proper sensory evaluation, these changes risk diluting long-term brand identity. Any ingredient change carries a flavour risk, regardless of the reason why. Just as malt from a new season requires careful assessment, changes in cereal grist should be evaluated to avoid unintended impacts on flavour and consistency. Sourcing hops locally can deliver significant sustainability benefits. It reduces transport-related carbon emissions, supports regional agriculture, and can strengthen supply chain resilience. But from a sensory perspective, local hops aren't without risks. Even the same variety grown in different climates or soil can show variations in oil composition and flavour expression. For example, a Cascade hop grown in Germany or the UK is unlikely to replicate the aromatic profile of one from the Pacific Northwest. And this means flavour drift is a real possibility, and switching hop supply should never be treated as a direct swap. Structured sensory validation is once again essential to ensure the beer continues to deliver the brand's expected aroma and balance. Otherwise, a sustainability gain could come at the expense of flavour consistency. Hop products are often positioned as a sustainability win, and for good reason. Using extracts, oils, or enriched pellets such as cryo hops or Type 45s can reduce brewhouse and cellar losses, improve yield, and cut down on wasted raw material. They also lower shipping weight, require less cold storage space, and offer more consistent utilization than traditional hop formats. However, the sensory story is more complex. Isomerized alpha acid extracts may provide consistent lab measurements, but perceived bitterness is often reported as higher, creating a harsher or more lingering impression compared to kettle-derived isomerization. Similarly, enriched pellets shift the balance of hop oils. While certain aroma notes may be intensified, others may be underrepresented, subtly changing the beer's characteristic flavor. Oils and extracts simplify dosing and reduce variability, but they need to be adopted cautiously in order to fully replicate the layered complexity of whole hops where multiple varietal compounds overlap and interact. And so, because of this, hop product substitution should be treated once again as a process change, not a one-to-one replacement. Structured sensory validation is important. Directional testing and descriptive profiling help determine whether the beer's flavour is maintained, subtly altered, or at risk of flavour drift over time. Breweries looking to reduce energy and water might look to adjust their cleaning protocols. So, for example, by recovering rinse waters, lowering cleaning temperatures, or shortening rinse times. These measures contribute significantly to sustainability goals by cutting resource consumption and wastewater volumes. However, these changes bring risks that can impact beer quality and sensory integrity. Shorter rinse cycles might reduce the effectiveness of chemical removal, leaving behind chemical agents such as caustic detergents. And these residues can cause off flavours, including harsh alkaline notes or chemical taints that degrade the beer's flavour profile. Water recovery systems, while environmentally beneficial, can again introduce contamination if not carefully managed. Recycled rinse water might carry residual chemicals or microbes, increasing the potential for chemical taints or microbial spoilage from biofilms and stubborn soil residues. Inadequate cleaning caused by insufficient rinsing or lower temperatures can also allow soils and biofilms to persist in the brewhouse and packaging lines to create hotspots for microbial growth that threaten product stability and shelf life. Even if sustainability changes target cleaning systems rather than brewing directly, the repercussions can still affect finished beer quality. Sensory validation once again needs to support the decisions to adapt cleaning protocols. So, sensory testing is as important as analytical and chemical testing. Analytical testing can tell you what's in the beer: alcohol, bitterness units, residual extract. Chemical testing can tell you how much of each compound is present, but only sensory testing answers the real question of, does this actually taste like our beer? Many sustainability-driven process changes don't cause immediate red flags on a spec sheet, but they can still affect flavour, aroma, mouthfeel, or the overall product impression. And often those changes are subtle. They build over time, and only a trained panel using structured sensory methods will spot them early enough for you to capture them. Before any brewery makes sustainability-related process changes, or any process change for that matter, it's best practice to have some solid sensory foundation in place. It would be impossible to assess the impact of process changes without first capturing a baseline sensory profile for your core products. And that means documenting what your beer is supposed to taste like, ideally through structured profiling using a highly trained internal panel or validated with a third-party descriptive profiling exercise. This is a good exercise to have or practice to have in place for your core products. This is a good practice to have in place for your core products, regardless of sustainability project management. After all, it's defining the flavor identity of your beer. Now, once a process change is underway, sensory input should be part of the validation. Apply just one change at a time, whether it's the new malt, a lower CIP temperature, or anything else that we've already touched on. In this way, the sensory impact can be isolated from other variables. And when testing, use directional sensory methods that go beyond just identifying a difference. Triangle tests tell you if something has changed, but not how. Difference from control testing, rating scales, or descriptive profiling offer a much deeper insight. So look for off notes, but also remember to assess whether the beer has drifted from your baseline, be that in aroma, taste, mouthfeel, or balance, and in which direction. A change might not be unpleasant, but any change is a shift away from the customer's expected flavour profile. Now, if you've identified a sensory impact, the next step is to refine the process, whether that's readjusting boil times, changing cereal ratios, or any other adjustment to overcome the variance. Once you've adjusted the process, you'll need to retest these changes and evaluate the sensory impact to confirm if the shift is overcome or continues to need refinement. Keeping detailed sensory records is important. Link the process changes to their flavour outcomes. Log what was adjusted and track how each decision performed. Document what changed, what was observed, and what actions were taken. This builds a valuable archive that not only protects brand identity, but also supports future process changes as you learn from past mistakes. Now, triangle tests I touched on a moment ago. They are one of the most widely used sensory discrimination tools. They're simple, statistically robust, and answer a clear question. Can tasters tell these samples apart? But that's also their limitation. A triangle test tells you if a difference exists, not what the difference is or whether it matters. In sustainability projects where changes can subtly shift a beer's flavour, understanding the nature of that change is crucial. It's not enough to know something is different, you need to know how and why. To get meaningful results from a triangle test, strict controls are essential. First of all 6 possible sample orders must be used evenly across assessors to avoid position bias. Each glass should be blind coded with random 3-digit numbers to prevent queuing. Testing should happen in isolated booths with no distractions, no talking, no eye contact, just focused evaluation. Samples must be presented identically in terms of temperature, volume, and glassware, or you'll introduce another variable. Assessors should be clearly told the objective, to find the odd sample, but not influenced by extra information. So don't tell them what you've changed in the process or anything that you're expecting to see. Finally, a triangle test also carries a 33% chance of a correct guess, so they require a really quite large number of tasters for statistical significance. Without these controls, triangle test results can mislead a lot more than they inform. And since triangle tests aren't directional, they can't tell you whether your beer has lost fruitiness, picked up an off note, or become unbalanced. Written comments can provide qualitative insight, but they can't be analysed statistically. Likewise, adding extra questions within the test or using too few assessors can produce misleading results. Triangle tests are a powerful statistical tool, but only when they're used as designed, and even then, they aren't the ideal solution for monitoring ongoing sensory consistency. A difference from control test offers a more precise way to track sensory changes during sustainability trials. Instead of simply asking, are these samples different, assessors compare each test sample to a known control and rate the intensity and direction of any difference. Using a -5 to +5 scale, you can capture whether an attribute is weaker or stronger and by how much, giving you valuable insight into both what has changed and how significantly. This method is especially useful for identifying subtle sensory drift before it becomes noticeable to consumers. For example, if a new malt results in slightly reduced malt sweetness and a mild increase in sulfur, a difference from control test shows the directional shift clearly. This approach is scalable, practical with trained panels, and ideal for tracking changes across multiple attributes, helping your brewers to preserve flavour integrity whilst optimising the process for sustainability. Descriptive profiling and rating scales go even deeper into the detail. Using a fixed scale, typically 0 to 10, trained panelists score defined flavour attributes such as diacetyl, mercaptan, DMS, or myrcene, and it's vital to use tasters who have been trained and validated on the specific flavour attributes you're asking them to measure, so that you can ensure that their findings are repeatable. This creates a quantitative sensory fingerprint of each sample. These results are often displayed on radar plots, which is a highly effective way to visualize multiple sensory attributes at once. Overlaying successive radar plots lets you quickly spot variation or drift from your baseline profile. By comparing scores across trial batches or over time, you can then see whether or not a change has occurred, but also which traits are shifting and by how much. By turning sensory experience into measurable data, descriptive profiling strengthens both internal decision-making and external communication, and it helps ensure that even as the process evolves, the flavour stays true to your brand. Now, once a sustainability change has been implemented, the next essential step is to embed it into your ongoing quality control system. And that means setting up new routines like regular sampling and testing of recovered CO2 for purity, monitoring oxygen ingress in a new pack format, or checking rinse water for chemical residues after cleaning adjustments. New equipment, whether it's CO2 scrubbers or CIP recovery skids, will require new preventative maintenance schedules to prevent performance drift over time. Sensory panels also need to evolve with your process. That includes training assessors on new compounds or elevated risk compounds. So that could be the sulfur compounds within the beer, astringency, or packaging related taints. Your QC system should adapt too, so update your sensory lexicon to reflect emerging risks. Identify new materials for regular sensory assessment, such as your recovered CO2, and make sure escalation procedures are clearly defined for known fault markers. For example, if DMS levels start rising after a boil time reduction, there should be a rapid response path to rectify the issue. Ultimately, sustainable change isn't complete at the point of implementation. It then must be supported by routine, robust quality control to protect flavour integrity for the long term. So, to wrap up, any change in the brewery, whether it's direct or indirect, has the potential to impact flavour. And that's why sensory validation is just as important as analytical data. Numbers won't tell you if your beer still tastes like your beer. By approaching sustainability methodically with structured sensory controls, directional test methods, and adaptive QC, brewers can reduce environmental impact without sacrificing what really matters to drinkers: flavour integrity and brand trust. So, the Aroxa team at Cara Technology can support the development of your sensory panel in a variety of ways. So, we can guide you on the key flavours in your sector, provide flavour standards to calibrate your panel, deliver taster training, and support the validation of your taster's proficiency. We also have an expert panel of tasters in-house should you want to explore profiling of your core beers with a third party. So if you'd like to explore any of those opportunities, you can reach out to our sales team. The email address is sales@aroxa.com. We'd be really happy to help with that. Today's webinar is also an introduction to our upcoming e-learning platform, Nexus, where you'll soon find some self-guided training materials. It'll be a comprehensive learning resource covering brewing and beverage technology fundamentals, as well as microbiology and quality management. You'll also gain access to problem-solving tools for real production challenges and sensory training, including flavour standards, validation exercises, and guidance on building your in-house sensory panels. All of this is delivered through practical, interactive, self-paced modules, giving you the flexibility to learn on your own schedule. So you can learn anytime and anywhere. Nexus content is applicable for everyone from craft brewers to multinational brewers, and it complements our Aroxa kits, training courses, and consultancy, bringing all of our expertise together in one platform. If you'd like to sign up for updates about the arrival of Nexus, you can scan the QR code on screen here and give us some details. I'll pop this QR code back up on the screen in a moment, but it's now time to see if we've had any questions at all. I'm really grateful to you for having stayed engaged. I appreciate there was an awful lot of material in there. I can't see any questions on the Q&A, but if you have any, please throw them on there. Or like I said, you can email us at sales@aroxa.com after the session if you have got any questions, and we will endeavour to get back to them. So do we have any questions? Doesn't look like we do at the moment. So I am going to let you know about our next webinar that's coming up. The next in our series of webinars is in 3 weeks' time on October the 29th, same time as we were today, so 3 p.m. In UK GMT time or BST time. It's being led by our founder, Dr. Bill Simpson, who will be talking about the flavours and off flavours of no and low alcohol beers. There is an event link to sign up now on Eventbrite if you'd like to register for what promises to be a fascinating talk on something that's a hot topic for brewers all around the world at the moment. Keep an eye on our social media. We will be sharing more information about how to sign up for this webinar as well over the next few weeks, but it should be a really good session, one I'm looking forward to listening to myself. Still no questions on the Q&A, so if you'd like to sign up for arrivals about the update, if you'd like to sign up for updates about the arrival of Nexus, you can scan the QR code on screen here and give us some details. I'm going to leave that up on the screen, and I will stay connected on this call for the next 5 minutes, just in case anyone has any questions they do want to ask in the background. Otherwise, I thank you for joining me this afternoon. I hope you found it interesting and valuable. And we will be sharing a recording of this onto our YouTube channel in the coming week as well. Thank you so much for joining us, and we look forward to seeing you next time in 3 weeks' time.